So another identity that we use during factorizing using algebraic identity is a square minus b square. And we know that is a plus b into a minus b. So let's try and solve a few questions based on this. Let's take 4 by 25 x squared minus 9 by 49 y squared. So let's try to find the values of a and b. So 4 by 25 can be written as 2 by 5 and x squared. So 2 by 5 x whole square. And then we can write 9 by 49 y squared as 9 as 3 by 49 as 7. So now we have the values of a as 2 by 5x and b as 3 by 7. Let's write that down. So our factorized version would be 2 by 5x plus 3 by 7y 2 by 5x minus 3 by 7y. So that's our factorized form for this. Moving on, let's try another question. So in this question, we'll need to solve out by first understanding what's happening over here. So let's try to take out all the common factors here. So we have 7 and 28. So we know out of 7 and 28, when we take out a common factor as 7, we are left with 3x minus 4y whole square minus 4, 2x. This 4 can go inside the square bracket, and we can write that as 7, 3x minus 4y square minus 2 into 2x minus y whole square. Then close that. Now we can use the identity on these two. We'll do that. Let me write that down so that it's more clear. So our a value would become 3x minus 4y, and our b is 2 into 2x minus y, or we can also write 4x minus 2y. Let's try. So 3x minus 4y plus 4x minus 2y is bigger. And the next one would be 3x minus 4y minus 4x. Let me open these brackets. Let's simplify. So we have 3x and we'll keep the 7 outside. So we have 3x plus 4x. We have 7x minus 4y. And then we have 3x minus 4x is minus x minus 4y plus 2y equal to 1. We can take out the negative. And then we have minus 7 into 7x into x plus 2y. And this is the final factorization for our expression. This might look a little bit lengthy, but this is very good to create an intuition so that you can solve any kind of question. And if you have any queries, don't forget to put those queries in the comment section. Let's try another example. So we have a squared minus b squared plus 1. So in this again, we'll create some terms. So let's take this. So follow the rule that we have already over here. So we'll keep these two in the first one and these two in the second one. So let's write that down. So we have a square b square minus a square as the first term minus b square minus 1 b square minus 1. This minus 1 is arithmetic common over here. So let's just write a square will be common factor on these two. So that would be b square minus 1 again. And here we have minus 1 b square minus 1. We'll take b square minus 1 as the common factor from both the terms, and then we'll left with the quotient a square minus 1. So that would be the first step of our factorization. We can factorize this further using a square minus b square, but we'll put them individually. So in the first one, we have this would be b square minus 1 square, and this would be a square minus 1 square. Let's write b plus 1 into b minus 1. That's the first one. And then we have a plus 1 into a minus 1. So this is the final factorized form for this expression. So next we'll look at factorization of trinomials. So basically we can represent the trinomial in the form x squared plus px plus q. And p and q are integers in this. So we'll assume that this can be factorized to x plus a into x plus b. And then we can write that down as x squared a plus x square plus a plus b x plus ab. So in such a scenario, we need to have a, b such values that it is equal to p. So a plus b should be equal to p, and a into b would be equal to q. So this is the rule of thumb that we are going to follow while factorizing any trinomial. So I'll use these and let's get started. So first example is 9x squared minus 9x plus 40. So now we need to find two integers. We need to find two integers such that I'll take the integers a and b, and we need to find a plus b as minus 9 and a into b as 20. So we can easily solve that. So let's write that down. So we have a is equal to minus 9 minus b, and ab. In ab we can put this as minus 9 minus b equal to b equal to 20. Sorry, cut. So we have to find something up along this line. So we can see that we have to do a bit of trial and error. So if we think that we have minus 4 and we add minus 5 to it, we'll get minus 9. And if we multiply minus 4 by minus 5, we'll get 20. So this is our assumption. And then we'll use these factorize our expression. So we have x squared minus 4x minus 5x plus 20. Now we'll factorize. We'll take two terms here, and in x squared minus 4x, we have a common term of x, and that gives us a quotient of x minus 4. In minus 5x plus 20, we'll take a common quotient of minus 5, common factor of minus 5, and this leaves us with a quotient of x minus 4. And that is the same over in this term. So now we can take that as common as well. So x minus 4, and then we multiply it to x minus 5. So this is our factorization of the above expression. We'll try another question. So here we have 3x squared minus 10x plus 8. So here we need to find a plus b such that, a and b such that a plus b comes out to be minus 10 and ab is equal to ac, because here we don't have just x squared, we have 3x squared, so we'll need to multiply them 3 into 8, and that is, so what value will give us in addition as 10 and in multiplication as 20. So what I tend to do is, because I know we need to get a multiplication of 24, I tend to do this 24 into 1, 12 into 2, 6 into 4, and there we go. We already got it. I'll write just the next one up. 6 into 4. So if we add minus 6 and minus 4, we'll get minus 10. And if we multiply minus 6 into minus 4, we'll get 24. Let's try this. So we have 3x squared minus 6x minus 4x plus 8. We'll take the common factor from these as 3x. We have x minus 2 minus 4. We'll take the common factor as minus 4 here, and we again get x minus 2. Now we can take x minus 2 common here, and our quotient would be 3x minus 4. So that gives us the final factorized value for this question. Now we have another question. Here we have x minus 2y as something that can be represented. If we put this as, say, a, we can simplify this equation. So let's simplify this expression. So that would be 15a squared minus 8a minus 16. So let's first solve this one. So we need to find something p plus q such that it is equal to minus 8, and p into q would be equal to 50 into minus 16. And that is minus 240. So following the simple trick that I did already, so we have 240 into 1. We can try 120, 30 into 8, 15 into 16. And these don't seem to work, right? There's another way. So we have 240, and we have 24 into 10. We have 12 into 20. And there we go. we got 12 into 20. So if we have minus 20 plus 12, we'll get the value minus 8. And if we have minus 20 into plus 12, we'll get minus 240. We'll use these. So we have 15a squared minus 28 plus 12. Let's take the common factor in this one. We'll do the same here. Take the common factor as 4, and that will give us a quotient of 3a minus 4. We'll again take the common factor of 3a minus 4, and this gives us the quotient of 5a plus 4. Now we finally need to substitute the value of a, and that is x minus 2y. So we'll write 3 into x minus 2y minus 4 into 5 x minus 2y plus 4. And solve this. We get 3x minus 6y minus 4 into 5x minus 10y plus 1. And this is our factorized form for this expression. Now let's come to the final part, which is division of a polynomial by a polynomial. So we'll just do an example based on this. So we need to find, so in this division, we'll need to find, first we need to find the common factors, or like factorize this to make our division easier. So let's take the bigger value, that is 45x to the power 4 is 28x squared. So here we can take actually the value of x and x squared as common. So we'll have 45x squared, x squared minus 3x minus 28. If we factorize this, we'll get a lot easier version to which we can use for division. Let's try this. X squared minus 3x minus 28. So our factorization should be such that a plus b is minus 3 and a into b is minus 28. Let's try it out. 28 into 1, 14 into 2, 7 into 4. There we go. So we have minus 7 plus 4 will give us 3, and minus 7 into 4 will give us factorize x squared minus 7x minus plus 4x minus 28. We'll take x as common. We are left with x minus 7. In the second one, we'll take 4 as common. So we are left with x minus 7. And then we have x minus 7 as the common factor. Then we can write x plus 4 as a remaining quotient. So we simplified this part into x minus 7 and x plus 4. Let's write that down. So we have 45 x squared into x minus 7 into x plus 4. And we need to divide it by 9x x plus. Now by factorization, we found that x plus 4 is a common factor for both of these. So we can cancel these out. Cancel the x out. And we can also simplify this. So our final value comes out to be 5x into x minus 7. That's how we solve it. Thank you for watching our channel. Please don't forget to like, share, and subscribe for more videos like this.